Hello guys, welcome to this video. So, how many of you are here? So we are going to do calculus today, and hi everyone. Let me just adjust a few things. Yeah, okay. So, we'll do calculus, and we will start with derivatives. So the first thing we are going to do is derivatives. So after that, we can move on to integration. So there is a recent video I posted about chain rules, and if you have seen it, you know that like chain rule can be used to solve almost every derivative problem, to find out the derivative at least. And there are other things in derivatives that will also help you, which I'm going to show in this video basically. So let's start with the problem. And also, if you guys have any voice is low, like, just give me a moment. Can you turn up your volume probably, because it seems fine to me. It seems fine to me. Maybe it's a issue of volume. Okay. Yeah. So we'll start with derivatives first, and then we can move on to integration and stuff. Okay. So first of all, when finding derivatives, I would try to go from the very basic. So given a function f of x, this function is called differentiable when the left hand derivative and the right hand derivative both exist. Okay. So this is the basic definition of differentiability. Given a function f of x, its left hand derivative and its right hand derivative, they must exist and they must also be equal. Okay, so they must be finite. But in order to see what LHD and RHD basically are, so anyway, the voice is fine, right? You guys can hear it now. So what is the LHD? The LHD is basically, let's say we are trying to find out f dashed of a. So we are trying to investigate the differentiability, let's say at some point a. Okay. So that would mean the LHD is limit h tends to 0 minus, and we should have here f of a plus h minus f of a by h. Okay. So like this, do you mean like this? Yeah. So basically, if you were to watch this total explanation and then solve the PIQs, I think you would be very much good with. It's not clear yet. I mean, I just checked with. I just opened my stream and checked the voice, so it was kind of clear with me. So can you please, can you guys like please recheck and let me know again, because it seems clear to me. Also, I will just adjust the mic here. Is that fine now? Is this fine? Is it clear? Okay, let's continue here. So basically what I was saying, left hand derivative, right? Left hand derivative, which is basically LHD, and this LHD can be written as limit h tends to 0 my. Yeah, like right now, is this position okay? Like, is the voice clear right now? Is what I'm asking. So I would just not touch it, anymore. Whatever works, works. Okay. So LHD is limit h tends to 0 minus f of a plus h minus f of a by h. And when I say h tends to 0 minus, what I mean is basically that if you have this axis here and this is your origin, then along this region in the negative side of 0, there is a value of h. So h belongs to the interval minus epsilon to 0, where epsilon is very small. Okay, great. Hello everyone, by the way. Hello Tufail Ahmed. Hello Roasted Chicken. Hello MJ Gamer. Hello Story Hub. Hello Aryan Singh. Hello everyone. So this is called the left-hand derivative. Okay, we are going to see a few of the examples. And what is RHD? So it is again the same thing, but this time the limit will go from the right hand side. The limit would be where h would be positive. So limit h tends to 0 plus f of a plus h minus f of a whole divided by h. This is called the RHD. Okay, so LHD, RHD, and only if these two are equal, so we say that f of x is differentiable at x equals to a if and only if. So IFF, notice that if and only if LHD is equals to RHD, and these two are basically finite, and this also equals the value of f dash a. If all these things are met, if all this criteria is satisfied, you can say that fx is differentiable at the point a. Correct? Let's see some examples. So this is a very important example which I'm going to show now. So if you have any doubts about differentiability, please ask in the chat. So first of all, let's say we have a function f of x equals to mod x. Okay, this is an example I want to show because this is kind of the standard example that you will be given when doing differentiability sums, and a lot of examples will revolve, lot of problems will revolve around the application of this particular example. So f of x equals to mod x, and we want to see if f of x is differentiable at x equals to 0. So this is what we want to see, if f of x is differentiable at x equals to 0. Okay. Okay. So how do we do that? So first of all, we need to see if LHD and RHD for this function is equal or not, and also if they exist or not. So what would be the LHD? LHD. Okay. So we want to find f dash 0, right? We want to check the differentiability at 0, the point 0. So keep that in mind. LHD should be limit h tends to 0 minus f of 0 plus h. Remember in the definition it was a, so right now it is 0. Then simply subtract it from f of 0 divided by h. This is your required LHD. Okay, this is your LHD. Now, how do you find the value of this? First of all, we can simply write this as, since f of 0 is 0, you can put 0 here in the function fx equals to mod x. If you put 0, f of 0 becomes 0. And now, in the left-hand derivative, we want to see what this limit can become if we were to put the values of f. So let's do that. This would be f of h minus 0 by h. So far, so good. Now, limit h tends to 0. F of h is nothing but mod of h divided by h. Now, this is what we have here. And also, obviously, we have 0 minus here. Okay. So, we have limit h tends to 0 minus mod h by h. Now, when h is 0 minus, this would mean that h is negative. However small the number could be, but it means that it approaches 0 from the left hand side, right? So it means it's negative. And what happens to numbers which are negative and those are inside the modulus? Basically, they come out as negative x. So I would just show it here. Mod x is basically x whenever x is greater than or equal to 0, and it is equals to minus x whenever x is less than 0. This is the definition of mod x. Okay. Now, this would mean that this value would come as limit. Now, when once we apply the property of mod, depending on h tends to 0 minus, we can simply now write limit h tends to 0 because the factor which separates this limit and that limit is already applied here. Okay, so this becomes minus h upon h. If you cancel them, it simply becomes 1. So the answer is minus 1. So our left hand derivative is simply minus 1. I think there are no doubts in that. If there are, please let me know. So this is how you calculate the left hand derivative. Now let's do the right hand derivative in a similar fashion. So right hand derivative should be equal to limit h tends to 0 plus f of 0 plus h minus f of 0 whole divided by h. This would give you limit h tends to 0 plus f of h by h, similarly like before. Okay, then this would mean limit h tends to 0 plus, and now we apply the value of f of h, which is mod h divided by h, and again h approaches 0 from the right hand side. That would mean that mod h is positive according to our definition of mod x, which we just did in the last sum. If h is positive, then mod h is positive h, right? Okay, so limit h tends to 0 plus h upon h, cancel it off, you get 1. The answer is 1. So basically this is your right hand derivative, and we found out that the left hand derivative was minus 1. So using these two values, we can conclude that the RHD is not equal to the LHD, which means therefore mod x is not differentiable at x equals to 0. A better property, a more generalized version of this proof can get you to prove, you can try it as an exercise. Mod of x minus a is not differentiable at x equals to a. This is a much general version. Hello Shivam, welcome to the stream. We are discussing derivatives and differentiability right now. Okay, so I would just let you have a look at the LHD first, and then you can look at the RHD, and then we can move on to the next problem. Okay. Okay, so this is the LHD and this is the RHD, and then we concluded that LHD and RHD are not equal, and that is why. Okay, this is the RHD, and the right hand derivative and the left hand derivative were not equal. Thus, mod x is not differentiable at x equals to 0. And the exercise that I want you to do is this: mod of x minus a is not differentiable at x equals to a. So this is what you should try, and this is a fact. You should remember this, that mod of x minus a is not differentiable at x equals to a. Okay. Okay. So we can do some other things here. Let's try and understand now. So differentiability can be composed and it can be solved in a lot of ways, but usually always try and go for this approach. It might be a little tedious, but this is the best approach there is to check differentiability. Also, in general, remember polynomial equations, exponential functions like e to the power x, trigonometric functions, these are differentiable everywhere. So you do not need to check the differentiability of sin x, cos x, tan x at any point. These are differentiable everywhere. Similarly, e to the power x, e to the power x square, something like that, and any polynomial in general would always be differentiable. So you do not need to check the differentiability of these things. If these are given, you have to assume that, okay, this is already differentiable. Let's go on to the next task, what we have at hand. Okay. Okay, so after this, let's try and understand a few properties. So, as I explained in that video, derivatives can be found out using chain rule, right? And I'm going to do it once more here. So anyone who is confused about finding derivatives or who takes time, if you hesitate to find a derivative, if you're hesitant about that, let's say you're given to find the derivative of e to the power sine of f of log x by x. Let's say this is the problem you have at hand. Okay, you have to find the derivative of d dx of e to the power sine of f of log x by x, where f is some function you do not know. How would you like find the derivative of this function? It's pretty easy. It's like super easy, but only if you know how to use the chain rule and how to use it efficiently. So can any one of you give me any answer for this one? It's a long one. So if you have watched that video, this would be an easier task for you because of the priority method that I myself use. That is how I learned when I first learned chain rule. And using that, this would be solved in like seconds. You, using that, you basically write the answer as you go. Okay. So anyway, give it a try, and I would try and do it after. So this is basically e to the power sine of f of log x by x, right? What I usually do in chain rule problems, in any derivative problem, is I have to identify the order of operations. So I would start from the very outermost section of the function. So I would see that, okay, this function is composed of a bunch of functions. And I need to find out in which order they are composed. Okay, so like in this question, you can see E is the first function we have. So E is 1. F dash log x into 1 by x into mistake in my text. What? There's a mistake. Anyway, so E is 1. E is the first one. Sine is the second function here, right? Then f is the third function here. And inside f, you have another function, so we would call it later on. Anyway, this f of log x by x is the third function, this whole thing. It's a division. And inside f, you have another thing, let's call it 3, 1. Correct? Okay. Now, let's try and do this. First of all, what is the first function? It's e. So basically, we will assume e to the power x. What is the derivative of e to the power x? It is e to the power x itself. So write down e to the power, and instead of x, write down whatever there was in that exponent. Sine of f of log x divided by x. Okay, this is what you had, right? So e to the power sine of f of log x by x. Yes, first e then sine function. That is correct. And okay, so multiplied by, what do you have? What is the derivative of sine? It's cos. So you have cosine of f of log x by x. Okay. First we did the exponential function, then we are doing the sine function because we are trying to go from the order of priority. So first priority is e here because e is the outermost function, right? So e and then sine, and now the derivative of sine is cos. We just wrote down everything there was. Now we are going to the inner function. What is the inner function which was inside sine? F of log x by x. So this is in the form, so we give a multiplication again, and f of log x by x is in the form, you would say, like division of derivatives, right? So u by v form of derivatives. So what do you do in a u by v form? You first square the denominator, so this is x square. Okay. Now you write x into, so yeah, Shivam, you've written something, d sine of dx is cos x, and then let log x as t. Here, you don't need to let anything for log x. You can simply do it because see, what is the differentiation of f of log x? So right now we have x square in the denominator because we are differentiating f of log x by x. Now in the numerator we have x into, now differentiation of f of log x. First of all, first function is f. So f dash of log x into 1 by x because for log x, right? The next function is log x. So this is simply the derivative of f of log x minus, and now you have f of log x into derivative of x, which is just 1. So we don't need to do anything here. Okay. And I think we are pretty much done here. So this is your required derivative. So I hope you understand how the procedure goes. Yeah, and also as per Shivan's method, so if he's saying that we can take log x as t, that will also work because if you were to take log x as t and you were simply differentiating f of t, right? That method would look something like this. So if you have a function which is y equals to f of log x, right? And he said that we should take t equals to log x. So this would also work. I will just show how technically, like if you were to do it in a subjective paper. So basically this becomes f of t, right? And you need to find dy by dx. So okay, let's do dy by dx. Then this would become f dash t into dt by dx. And what is dt by dx? From this you can get dt by dx is nothing but 1 by x. So this answer becomes basically f dash of what is t? T is log x. And what is dt by dx? It's 1 by x. So the answer becomes this. Yeah, right? So yeah, chain rule and doing derivatives, it's pretty easy stuff. And you just have to be, careful about it, about not to mess up the order of functions. And otherwise you're just good. You're just fine here. You would be able to find out any derivative here. Okay, so let's try and do a few functions. Okay, so let me choose a question from here, which we can try and do. So suppose, yeah, I see a question here. So this is a good one. So I think we have a question which looks like this. Y is equal to, the daily time is like around, like 6:30 to 7 every day. 6:30 to 7, maybe 7:30, somewhere around that. And every day I'm trying to, I have started from the last day by putting out a poll and discussing. So last day, I think there were like 30 or 20 responses. And people said that they wanted to see calculus, so which is why we are discussing calculus right now. And there would again be a poll today, where you can vote, and I would be discussing that topic. Okay, so we have a problem here as well. 1 plus another similar problem, cos square of x square, and we want to find out y prime at pi by 6. Okay, so what would be the value of this? So based on what we just learned here in chain rule, and we also learned differentiability. So this is a question that we want to study here. So let this be number one actually. This is basically our first question right now in the stream. So y equals to root over of 1 plus cos of x squared whole square, right? And we want to find out the value of the derivative of the function at pi by 6. Now, using chain rule, this is again pretty easy. So what do you want to do here? You first want to identify the order of functions. So first of all, in this function, if you observe carefully, square root is the first one, right? Because we are starting with a square root. So this is our first function. And then this is your second function. And inside your second function, you have this cos square stuff, which you can do again. So dy by dx should be equals to, firstly, what is the derivative of root x? It's 1 by 2 root x, right? So 1 by 2 root 1 plus cos square of x square multiplied by, now the derivative of 1 plus cos square of x square, which is 0, plus, now the derivative of cos square of x square, you can again do numbering here. First function is square. So the first function is x square because cos of x square whole squared. So the outermost function is basically similar to x square, which is why the derivative should be 2x. Or in other words, 2 into cos of x square multiplied by the next function is cos, which means it should be minus sine of x square. And then for x square, we should have 2x. Okay. So if you do this, here we have this would become 2 into cos square, cos of x square into sine of x square. This is the formula for sine 2x. So this basically becomes sine of 2x square. So in the numerator, you should simply have, I think, minus 2x sine of 2x square divided by 2 times root over of 1 plus cos square of x square. This is basically your function. Okay, this is your function. And now if you put pi by 6 in this, you would get your value. So simply put pi by 6, and whatever the value is, you just have to get it out like that. There is no need for simplification or anything. And they could have asked also like something like 0 or something, x equals to 0. Even that would work, and that would make the answer as 0. But okay, so that's a complicated answer just for the sake of calculation, but the question was easy. This is how the questions are usually formed. So I'll just leave this on for a moment in case anyone has any doubts here. Okay, so let's go to next page and write down another question we have. Let's say we have this thing where y is equals to root over log x plus root over log x plus root over log x plus dot 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 and so on up to infinity. Then what is the value of dy by dx? And I would also give you a few options here. So option 1 is x by 2 by minus 1. Option 2 is x by 2y plus 1. Option 3 should be 1 by x whole into 2y minus 1. And option 4 should be 1 by x whole into 1 minus 2y. So these are your four options, and these are the questions here. Hello Ritvik, which one do you want to repeat? What do you want me to repeat again? Yeah. Which part do you want me to repeat? Please let me know which part you want me to repeat. This is the question you have basically. Okay, so like you have this thing y equals to root over of log x plus root over of log x plus and then root over of log x and stuff. And you are asked to find out the derivative of y, which is dy by dx. You have your four options: x by 2y minus 1, x by 2y plus 1, x 1 by x whole into 2y minus 1, and 1 by x whole into 1 minus 2y. So do you guys want time to do it, or should I start? Okay, so you wanted last question to be repeated? Yeah, sure. Did you want this one, Ritvik? So this question was y equals to root over of 1 plus cos square of x square, and we basically had to find dy by dx, and then it's just easy to find the value of y prime of pi by 6 once you get the derivative. And I will just explain this one more time here. So first function is root over, right? The functions begins with a square root. So 1 by 2 into square root of cos square of x square multiplied by 0 plus, now we are doing the inside, so derivative of 1 is 0. And then for cos square of x square, we can do 2 into cos of x square whole into minus sine of x square into 2x. Because you go line by line. You go like 2 into cos of x square, and then you go for cos, it is minus sine of x square, then you go for x square, which is 2x. And you just simplify it. We apply the formula of sine 2x, which is 2 sine x cos x, and you got the answer. Right. So this is, and then you can put the value of pi by 6 in terms in place of x to get your value. Okay. So, and this is the question I have on board right now. So do give it a try. I'll be back in 5 minutes. Yeah. So this is the question on the board for everyone who is here. This is the question on board. Please go do give it a try. And I'll be back in 3 to 4 minutes, max 5 minutes. So probably do it by then. I think this should be done by then. Try to think how to evaluate an infinite series first. That would help. Recursion is a good tool always. Okay. Hello everyone, welcome. Okay, so did you guys solve this? Yeah, I see a lot of you have solved it. Three option. Okay, option three. Okay, option three. Let's do. Let's try and do it. First of all, y equals to root over of. Let me draw it correctly. Root over of log x plus root over of log x. Now, what I know is you guys have solved it by assuming that this part is y. I understand that. If this was a subjective problem in ISI, and let's say the marks was 10, first you guys tell me if this is how you did it, okay? So obviously, if this is y, this is y2 because there are infinitely many terms, okay? So that means that we must have y equals to root over of log x plus y, okay? This would mean if we square both sides, you get y square minus y equals to logarithm of x. Okay, this is what you did, right? And then you differentiated this to get 2y into dy by dx minus dy by dx equals to 1 by x. So this is what you guys did, right? And then you just solve for dy by dx, which is simply dy by dx equals to 1 by x whole into 2y minus 1. If this is the case, the thing is, in a subjective exam, let's say if the marks are 10, you will end up getting 3 to 4 out of 10. You should get a 3 to 4 out of 10 if you were to solve it like this. Do you know why? Can someone tell me why does this approach yield you 3 to 4 only out of 10? And why not more? Why is it not a perfect 10 out of 10? We will not consider that, okay, there is some step jumps and all. We are not going to consider step jumps and stuff like that. In any subjective exam, in like ISI or CMI, no one cares about that. They care about your concept and knowledge and whether you are applying something which you haven't justified. So, what is the problem here? This is very good for us objective and it is good because it works. But if it didn't, then the answer could have been not defined as well as. So, why does it work and what is the problem here? What is the problem with this approach of letting this thing as y and then differentiating? Hi, A, B, C, D, E, F, G, H. Okay. Invitation in okay. See, what I'll do is you're asking for the notes, right? So, give me some time. If you want the notes for BStat, I don't know if I have much of them left, but whatever I have left, you have to please also mention the subjects you need. If you need like probability or stuff, so just mention that, okay, I need probability one and stuff like that. I can share that. I guess I have probability. Okay. So the problem with this method while solving this problem where you have y equals to root x, root over log x plus root over log x and plus dot 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 all those root over log x, right? And you are assuming that okay, this thing here is y because obviously this is an infinitely there are infinitely many terms and this repeats itself, so according to recursive methods this should be y. Okay, but the thing is, how do you know if this series converges and what are the values of x for which this series converges? we have not proven we have not proven the convergence of this infinite radical, if you might say that. So all of them done in ISI. Okay, okay. What I'll do is I'll tell you ABCD that once I get the notes I have available already, I will send them to you. And if I get more, I will do that definitely. Okay. Okay. So this is what you have like y equals to root over of log x plus all the way this log x thing. And now you have not defined the you basically haven't done the convergence issue here, right? Okay, there is a convergence issue, but okay, for objectives, this is fine. This works, and this is your answer. But for subjectives, this won't work. That's what I'm saying. Okay, that's what I'm saying. Okay, let's do an interesting problem actually. Let's do a very interesting problem, and that would be a good start here. So Okay, so you guys have already seen this kind of problems. These are called implicit differentiation problems. So let's try and do, okay, let's say we have problem number 2. Okay, so this is problem number 2, and we are trying to write y is equal to logarithm of tan x and the basis sin x. Okay, and we want to find out the value of dy by dx at the point pi by 4. What is the value of this point? Value of this derivative at this point. And let me give you four options again. So the options are 4 by log 2 minus 4 log 2. Number 3 is minus 4 by log 2. And then the number 4 is none. Okay, so these are the four options you have, and this is the question. Y is equals to log of tan x base sin x, and you have dy by dx. You need to find out the value of the derivative of y at the point x equals to pi by 4. So you're saying none. Okay, let's find out. Does anybody need any more time for this one? Okay, let's try and do it. Okay. So the crafty girl is saying none. Let's try. So y is basically log of tan x and the base is sin x, right? Now we know about logarithms with like multiple like bases and normal bases here, indices. We can write them as log of tan x by log of sin x. This is what we can do with logarithms, right? And what can we do to differentiate this? We can do dy by dx equals to, now we can do the same thing, log of sin x whole squared and then log of sin x multiplied by now the derivative of log of tan x. So essentially we are first doing the u by v rule for differentiation. So log of sin x would be here and multiplied by log of tan x derivative. The derivative of log of tan x should be 1 by tan x into derivative of tan x, which is x square x. So x square x by tan x. And let me write it separately here. Minus, again, this should be log of tan x into derivative of log of sin x, which is nothing but cot x divided by log of sin x whole squared. That is clear, right? Now we just simply have to put pi by 4. Okay, let's try and put pi by 4. So what is log of sine of pi by 4? Sine of pi by 4 is 1 by root 2. So this basically gives you minus half log 2. This term log of sin x. If you're not sure why, try and use the property of exponents inside logarithms. 6, so cos of pi by 4 is 1 by root 2. Sec of pi by 4 should be root 2. Sec square of pi by 4 should be 2. Tan of pi by 4 is 1 divided by, again, log of sin x we already discussed. It was minus half log 2. So if you square it simply, this only gives you, let's keep it like this. This is visible. Yeah. So minus half log 2 into 2 by 1 divided by, now log of sin x whole square should be minus half of log 2 whole square, which is 1 by 4 log square of 2. Now let's repeat the same thing. Log of tan of pi by 4. Tan of pi by 4 is 1. Log of 1 is 0. So this is basically 0. Because tan of pi by 4 is 1 and log 1 is always 0. If one term is 0, then it does not matter what you're doing with the other terms, right? It's basically 0. Okay. Now simplify this. Log 2 and log 2 cancels and this 4 goes above. So you basically have minus 4 by 2 into 2 divided by log 2, and the answer is minus 4 by log 2. So this is your answer, minus 4 by log 2. So we can check the options here. I think then option 3 is correct. And the question was this: y is equals to log of tan x base sin x. We were to find dy by dx at the point x equals to pi by 4. And So it is hard indeed. It is hard. I agree. It is hard. And the answer should be minus 4 by log 2. Is there any doubt in how we solve this problem? Please let me know. I would just go over it again if there is any doubt about how this we arrived at the conclusion of the problem. First of all, we use the fact that obviously log can be separated. So basically, if you have like, I will show it here. Simply remember this fact that if you have log A base B, this can be written as log A by log B with a base of your own choice. It does not matter. Any base works here. Any valid base works here. We will always take E because we are doing calculus and only ln of x works. So this is basically ln A by ln B. Ln means the natural logarithm. And using this, what we did here was that we first converted this log of sin x tan x base sin x to this. Hi, Monica. And I think the crafty girl, I think you have understood what we were doing here, or maybe you figured out where you went wrong, maybe some calculation mistake. Yeah, thank you. Great. Okay. So, and then we did dy by dx, and then we simply applied the chain rule, which we have learned in this very stream itself. If you do not know, you can just like go back to maybe 20 minutes. Yeah, thank you, StoryHub. I hope you understand what I'm teaching here. And so, well, this problem is minus 4 by log 2. Okay. Let's do one more problem and then we can probably call it a day. Let's do, yeah, let's do something which a lot of people would say, okay, this is complicated. Let's do a sum like that, okay, which people might say complicated. Okay, this is problem 3. So we want to find the derivative of tan inverse of root over 1 plus x square minus 1 by x with respect to the function tan inverse 2x into root over 1 minus x square by 1 minus 2x square. This is what we want to do, and we want to find this derivative at x equals to 0. And then again, there are four options. One is 1 by 8, 2 is 1 by 4, 3 is 1 by 2, and 4 is 1. Okay. Okay. So these are the problems we have. These are the options we have, and this is the problem. So basically, tan inverse of root over 1 plus x square minus 1 whole divided by x, and we have to find the derivative with respect to tan inverse of 2x into root over 1 minus x square whole divided by 1 minus 2x square at x equals to 0. This is what we have to do. Okay. So the naive way of doing this would be simply trying to differentiate these terms and then divide the differentiations. Okay, divide your derivatives and then get a huge complex answer here. But rather, what we are going to do is we're going to do it the smart way. So let's say this function is y1 and this function is y2. And we simply want dy1 by dy2. Okay. So let's find out dy1 by dx. But to do that, first of all, we would like to substitute something here. So let's try and say that x is tan theta for the first problem for y1. What happens if x is tan theta? If x is tan theta, then you can see that y1 becomes simply tan inverse of root over 1 plus tan square theta minus 1 by tan theta. And this gives you, now 1 plus tan square theta is basically sec square theta, right? So in this expansion, in y1 equals to tan inverse of root over 1 plus x square minus 1 by x, if you were to differentiate it directly, this would give you a huge answer. Like it would be very complicated. But rather, take x equals to tan theta. I'm figuring this out because I already see a 1 plus x square in the numerator under root. And I already know, okay, that means this requires an trigonometrical substitution. And if I take x equals to tan theta, this expression simply becomes tan inverse of what is root over 1 plus tan square theta? This is sec square theta. And that means this would be sec theta minus 1 by tan theta, right? sec theta minus 1 by tan theta. Okay. And when you have this, when you have 1 over 1 plus tan square theta as sec theta, and then you get minus 1 by tan theta, now this is not so hard to differentiate. The reason being, now you can differentiate this and then find out the value at any theta, right? So let's try and do that. Let's try dy1 and let's see what do we get in terms of dy1. So dy1 should be 1 by 1 plus, you can actually simplify it further by writing 1 minus cos theta and then basically this, okay, let's simplify it further just for the sake of simplicity of the problem. Tan inverse, this is 1 minus cos theta by cos theta divided by sin theta by cos theta. Okay, cancel the cos thetas. This becomes 1 minus cos theta by sin theta. What is 1 minus cos theta? So 1 minus cos theta is simply 2 sin square theta by 2 divided by what is like sin theta. This is again 2 sin theta by 2 cos of theta by 2. Cancel them off. There is one of them left and cancel the 2's off. You get tan inverse of tan of theta by 2, which simply gives you the answer theta by 2, which is y1, right? So this is why you should use trigonometrical substitutions to understand this problem. So this means that dy1 by dx is equals to d theta by dx into half. Now what was our theta? So we had x equals to tan theta, right? We are going to find out the value of d theta by dx from that. So x equals to tan theta. Now if you do d dx on both sides, you will get excuse me, let me have a water break. Yeah. So where were we? We were here. Hi, actually, Crafty Girl and Bedtime Story. This is the only way to learn trigonometric practice. Mm, hmm. Well, if you are talking about like just the identities and you know how to do sums involving trigonometry, then no. But if you're talking why how to use these trigonometrical identities in derivatives and integrations, then yes. Hi Dhruv, yeah, I will bring a video soon on differential equations and a complete one at that. So that video would have everything you require, you would know, need to know about differential equations and how to solve almost every problem that has come in past year papers or that is going to come in your boards, stuff like that. Okay, so let's finish this problem. So d theta by dx is simply 1 by sec square theta, and 1 by sec square theta means 1 by 1 plus tan square theta, which is basically 1 by 1 plus x square. So our dy by dx simply becomes 1 by 2 times 1 plus x square. Okay, this is your basic expression. Now we can do the same with y2. Y2 was tan inverse 2x root over 1 minus x square divided by 1 minus 2x square, I presume. Yeah. and we will do the same, but we are going to try and get a different substitution here. The substitution that works here is basically x equals to sine theta, and if you do that, you simply get tan inverse 2 sine theta cos theta divided by 1 minus 2 sine square theta. And in this way, you get tan inverse of sine 2 theta divided by cos 2 theta. And this would give you y2 equals to tan inverse of tan of 2 theta equals to 2 theta. Therefore, dy2 by dx is 2 into d theta by dx. Okay. So y2 can be reduced tremendously just with the help of a trigonometrical substitution. Always keep in mind whenever you see these expressions like root over 1 minus x square, root over 1 plus x square, always keep in mind you have to use trigonometrical substitutions. Do not be afraid to use them. Actually, my question should be how much, because I have this idea that I can only learn it by root. Um, how much of what can you tell me? I not relate it. And also, you said that you could make it through everything, but not integrals. Why is that? Like, what trouble do you have in integration? Right. Okay, so what is d theta by dx here? Again, similarly, like x equals to sine theta. This would mean, like, if you do d dx on both sides, one should be equals to cos theta into d theta by dx, right? Like this. And therefore, we can write that d theta by dx in the case of y2 is 1 by cos theta, and cos theta is basically root over 1 minus sine square theta. And you can express it in terms of x like root over 1 minus x square. And we put it here to get dy2 by dx is 2 by root over of 1 minus x square. And if we find out what we found for dy1, it was 1 by 2 whole into 1 plus x square. So previously we also found that dy1 by dx is equals to 1 by 2 whole into 1 plus x square, I think. Okay. Like how many problems? Integration, I do not think you need to solve, like, if I already think that you have solved a lot of problems, but if even by solving a lot of problems you still do not feel comfortable in that topic, that really means that there is something lacking in the concept section, like something which you may not identify, which you need to identify. But the thing is, like JE chapters, if you are trying to do a sum, it's already taking you deep into the concept section where you have to understand everything from the very bottom. If you do not do that, then these questions become unbearable because they are going to ask you questions that rely solely on concepts and then on a lot of calculation, manipulation, and techniques. So that is why concepts should be. I think you should focus on concepts first. Try a different book. Try some videos. Try some different materials. Probably that will help. Okay. So therefore, dy1 by dy2 is what the question asked us, and then this should be equal to I think root over 1 minus x square divided by 4 into 1 plus x square. And we had to find it at the point x equals to 0. So dy1 by dy2 at the point x equals to 0 is nothing but 1 by 4. Now let's get back to the question where it was. It was a long question. So yeah. So the answer for this question is number 2. Okay. This is your answer for the question, and 1 by 4 is your answer. Okay. Okay. So so I think I will end the stream here, and we can join back tomorrow, and we will do it again, our live stream again on tomorrow at the same time. There would be a poll, and you can select which topic you want to do. So bye everyone. Yeah, yeah, yeah. I appreciate you watching it actually. Thank you. Bye.